The mole ratio. How to relate the amount of one substance in a chemical reaction with the amounts of the other substances. We have already learned how to write a chemical equation from a statement about a reaction and to balance the equation so it reflects the law of conservation of mass. But what does the balanced equation mean? Aside from being needed to create a balanced equation, what are the coefficients of the reaction used for? Let's start with a simple combustion reaction for ethane. 2C2H6 gas plus 7O2 gas gives 4CO2 gas plus 6H2O liquid. The first meaning of the coefficients is the number of molecules that react and are produced. To reread the equation with this meaning, we have 2 molecules of ethane gas react with 7 molecules of oxygen gas to form 4 molecules of carbon dioxide gas and 6 molecules of liquid water. But there is another meaning to these coefficients as well, and that is the number of moles. If 2 molecules of ethane will react with 7 molecules of oxygen, then 2 moles of ethane will react with 7 moles of oxygen. This will allow us to relate the substances to one another with sizes we can actually measure in the laboratory. Suppose we had 4 moles of ethane. How many moles of oxygen would we need to react with it? Well, 4 is twice the coefficient of ethane, so we would need twice as much oxygen as is shown by the coefficient in the reaction, 14 moles. Suppose we had 6 moles of ethane. How many moles of carbon dioxide would we get? Well, 6 is 3 times the coefficient of ethane, so we would get 3 times as much carbon dioxide as the coefficient, 12 moles. Suppose we had 5 moles of ethane. How many moles of water would we get? This one is a little more complicated, but 5 is 2.5 times the coefficient of ethane, so we would get 2.5 times as much water as its coefficient, which is 15 moles. These 3 examples were done to show that you can connect any substance in the reaction with any other substance in the reaction. Let's look at one more example. Suppose we had 7.218 moles of ethane. How much oxygen would we need? This is probably not something most people can do in their head, so we need to develop a method to use in these situations. That is the mole ratio. The mole ratio is a conversion factor to convert moles of one substance into moles of another substance. So let's set it up like one. We start with a given quantity, 7.218 moles of ethane. Then we put in the conversion factor ratio form and the unknown. Now we need to find the relationship between the number of moles of ethane and the number of moles of oxygen. This, as we have just learned, is shown in the balanced equation for the reaction, which says that for every 2 moles of ethane, we need 7 moles of oxygen. So we place the moles of ethane in the bottom and the moles of oxygen in the top. Now we can do the calculation. 7.218 moles of C2H6 times 7 moles of O2 divided by 2 moles of C2H6 equals 25.263 moles of O2. Note that the unit, moles of C2H6, will cancel out, and we will be left with moles of O2. One quick note on sig figs. Clearly, 7.218 moles of C2H6 is a measured number and has 4 sig figs. But what about the 7 and the 2 in the mole ratio? These numbers are determined by balancing the equation, which relies on counting the number of atoms. So these are counted numbers and therefore are exact and have an infinite number of sig figs. This will always be true when using the mole ratio. So our answer is good to 4 sig figs, 25.26 moles of O2. So the mole ratio is used to find the moles of one substance in a chemical reaction from the number of moles of another substance in the chemical reaction. The mole ratio is produced by placing the coefficient of the unknown from the balanced equation in the numerator and the coefficient of the given from the balanced equation in the denominator. Let's do some sample problems with this same equation. I will give you the number of moles of the given and tell you what the unknown is. At that point, you should pause the video, set up the mole ratio, and do the calculation. Then restart the video to see that you have found the correct mole ratio and the answer. There will be 3 problems, so pause the video here while you collect the materials needed to do the calculation. Now we're ready to start. If 2.40 moles of O2 react, how many moles of H2O are produced? Pause the video and do the calculation. The mole ratio should be 6H2O over 7O2. And the answer to the correct number of sig figs should be 2.06 moles of H2O. The second problem is, if 3.92 moles of CO2 are produced, how many moles of C2H6 are needed? Pause the video and do the calculation. The mole ratio should be 2C2H6 over 4CO2, and the answer to the correct number of sig figs should be 1.96 moles of C2H6. The third problem is, if 5.18 moles of H2O are produced, how many moles of O2 are used? Pause the video and do the calculation. The mole ratio should be 7O2 over 6H2O, and the answer to the correct number of sig figs should be 6.04 moles of O2.